Okay, so I think I will continue the today's class from last class. So we talked about the industrial IoT systems. So do you have any questions regarding that? We are going to continue that section today, and we are also going to talk a little bit about data analysis of IoT networks and how we can use machine learning concepts to analyze the data. Okay, so in today's class, we are going to continue talking about the industrial IoT systems. So basically, we are going to be talking about the key enabling technologies of industrial IoT systems. Key enabling technologies. So um, basically, there are many technologies. So out of them, we have like the main technology, which is the artificial intelligence and machine learning, right? So artificial intelligence is something very trending right now, and it is useful for the industrial IoT systems. So um, the there are a lot of proposals to incorporate artificial intelligence into industrial IoT networks and also normal IoT networks. So in here, in AI, intelligent machines are and uh, developed and such kind of machines respond to us, respond like humans. Such kind of machines respond like humans. So in IoT networks, we are hoping to add these technologies to the devices such that the devices are able to make decisions on their own. One thing, and also the devices should be able to respond to the humans uh, in the environment in a very human-like manner without being like a computer. So the robots, let's say robots in the environment, in the industrial environment, uh, uh, can be programmed with artificial intelligence such that the robots can react to the environment in a human-like manner and interact with the humans, talk with humans, get input data from the environment, and so on. They will respond like humans in the environment, in the industrial facility. So basically, that is going to be the future. So still, I mean, research works are going on regarding that, and also industries are trying to implement this. However, the challenge is the cost of implementation. One thing, right? Still, cost wise, it's difficult to implement artificial intelligence in devices because the devices require a lot of space, memory, processing power, and accuracy, and like testing. A lot of testing must be done to achieve the accuracy. So these things require cost, I mean money, and like industries are not able to invest a lot of money still on implementing very high end technologies at the industries. However, universities and industries are having their own research on applying these AI technologies as much as possible to the devices in the facility, right? So robots are the devices in the facility, and sensor-based embedded systems, sensor nodes, can be embedded with artificial intelligence technology. So many research works and many industries are focusing on these like embedding AI into uh, embedded systems, right? Embedded systems plus AI. So uh, if you're doing, for example, higher education, and if you're going to go to industry, sometimes they will be looking into this, like um, how to install the AI technology in embedded systems. So we have embedded like microcontroller based like a system with many modules in it, like communication modules and storage units, processing units, and so on. So how we can implement AI and or machine learning is the challenge. So we need to consider how we can do it within the small space that is available. And like we need to start small, and we need to do some small AI implementations, and once they're successful we can improve the performance for like large AI applications. So uh, so still the work is going on regarding embedded systems and AI, incorporating AI into embedded systems. So once if this is possible, like a lot of appliances can be, embedded. I mean, a lot of appliances with these embedded systems can be incorporated with the AI technology, which means that they can give some output to us and give some useful information to us. So that is going to be like the possible like future for IoT networks in general. So since we are talking about industrial IoT networks, the industries also will be able to improve their product, like they're producing they are trying to improve their products. So the performance of the um, products and the demand for such kind of products will also increase. So the demand for AI based products will increase in the future. So therefore this is one of the technologies that people are looking into in incorporating in the industrial scenario. So currently works are going on regarding that, and some are in the research level. So demand for AI based products are increasing, and uh, therefore a lot of research works are done regarding this. So I talked about the artificial intelligence or AI. So what is ML? What is machine learning? So what is the difference between these two? Right. So you might ask, what is the difference between machine learning and AI? So machine learning is a subset of AI, right? So if you can consider AI as the biggest set, then part of it is like machine learning, right? So a machine learning lies within the AI field, right? So machine learning is a subset of AI, and machine learning is where we install some kind of algorithm in a machine, such that the machine can make more accurate decisions than using other methods. Okay, so machine learning is like a kind of an algorithm, right? Machine learning is implemented as an algorithm, is implemented as an algorithm that will be implement that will be uh, is implemented as an algorithm in a in a machine and it can it can make accurate decisions based on data. So based on data, it makes accurate decisions. So data is the main thing in machine learning algorithms. So you need to have proper data set and you need to create the correct data that is required for your application, and you need to utilize that properly for your application. So based on your application, you need to choose the type of machine learning that you'll be using, right? So machine learning also can be, like divided into different types. Okay, so machine learning can be divided into mainly 3 types. So we will talk about that in the next next steps of this lecture. So first I will just give a small introduction to these enabling technologies. Okay, so we are talking about the key enabling technologies for the industrial IoT systems. Okay, so industrial IoT networks. So these technologies are useful for the general IoT networks as well. However, like industrial IoT basically will require these technologies to improve their performance in terms of product manufacturing and improving the performance of their products. So we will talk about the key enabling technologies, and we will get into more detail regarding artificial intelligence and machine learning in the next steps. Okay, so if you have any questions, please let me know. Also, can you please let me know whether you have learned machine learning in a previous module so far? I mean, have you done some kind of a module in SLTC or, I mean, in SLTC before regarding machine learning? Yes or no? Okay, so I don't know whether you have learned machine learning or not. However, I think you will be learning machine learning in the upcoming I mean modules that are offered to you in the next semesters. So like it's a very demanding area, and you can apply it to any kind of a field. So when you take industrial IoT or IoT networks in general, you can use artificial intelligence, machine learning concepts to those I mean networks and those systems. So it's good if you can learn that so that you can apply it for any kind of, I mean, most of kind of applications that are available, especially in communication systems. So cybersecurity is another key enabling technology that is required for industrial IoT systems, right? So cybersecurity is a technology which enable us to communicate in a secure method, uh, right? In a secure method. So cybersecurity is about securing the data and I mean protecting the data and also protecting the privacy of the data. So So basically, there are many technologies that can be used to improve the cyber security. So one of the, technologies that are popular these days are blockchain technology. Blockchain technology is a technology which allows us to create like a authentication method that allows only certain like authorized users devices, users to access certain data in the network. So blockchain is a technology that enables cybersecurity and stops like intruders accessing your data. And encryption, decryption methods can be used to secure the data. Then we have like authentication methods like we can allocate username passwords for different accounts, and we can only allow the people with the correct username and password to enter the account. Apart from that, we can add a second step authentication methods, right? Like two-step authentication methods, right? Two-step authentication methods can be enabled to enable only the people who are authorized to enter the network. So two-step authentication, verification can be done using apps like Google Authentication app. So there are other authentication apps also available. So you can use these kind of apps to get the code to access your data, and you can increase the security of your login much in a much better manner when you use these kind of technologies. So the third technology that okay, so in the industrial scenarios, still sometimes it is said that the industries are not willing to share their data with the cloud servers. So due to the fact that the industrial data will be exposed to the public, but once you actually have large volumes of data, it is very kind of difficult for you to handle all the data within your infrastructure. So inside your industrial network, it is difficult to manage large volumes of data. So in cases where you have large volumes of data, you can use you can store those data in the cloud computers. So instead of keeping all the data in your own local network, you can keep it in the cloud servers, right? So you can use like third party cloud server providers and use their services. So such kind of third party service providers, cloud service providers will provide all the security that is required, and it will recover your will be uh, provided by them. So therefore the amount of services that are provided by the cloud service, it will be high. So rather than your own data handling, then data can be managed very easily using the available third party cloud service providers. So with low cost, you can I mean manage all the data in compared to the situation where you are managing all the data yourself. So cloud computing is like a good technology that can be integrated into IoT systems, and also for the industrial IoT systems. So industrial IoT systems, as I discussed in the last class, will give the priority for the connectivity between the devices, or the sensors, in the industrial facility, right? So in the industrial facility, there will be a lot of sensors that will be connected to each other. So these communications will uh, will consist of data that is useful, and such kind of useful data can be like processed in the, access point based edge server, and then a cloud server, right? So handling data is going to be a challenge in the industrial IoT systems, right? So large volumes of data is a challenge. So in order for us to get a good organization of the data, we need to we can upload it to the cloud servers. Okay, so cloud computing can be a solution to manage the data, and also it can, apart from the storing of the data, it can like manage the data, it can analyze the data, right? Analyzing the data means like it can provide some useful insight into the data. It can observe useful patterns in the data. So it can observe patterns in the data. Patterns in the data will be useful for people like planners, like who are planning the industrial who are planning the industrial facility and its functions. The patterns will give them an indication like what is required to be done in the future, and so on. So future can be predicted using these kind of like analysis of the data. So so therefore cloud computing is a good technology to be enabled in this industrial IoT systems. So it is one of the crucial or most important technologies. So right, so like cloud computing, edge computing is also important, right? So edge computing is used at the edge of the network, right? So at the edge of the network where the access point is collecting the data, we can actually have the edge server. So edge server will be useful for us to uh, say only, process the data. I mean, firstly, the edge server will be collecting the data, and then it will be processing the data. Processing the data means like it will check like what data is required and what data is not required, and so on, and send only the uh, useful data, right? Send only the useful data to the cloud servers, right? So if we are connected to the cloud server, then we can send to the cloud server, right? So we learned about another type of computing, which is fog computing, right? So we can send to our fog server as well if it is required, right? So based on the traffic, the data cannot communicate or data cannot travel as far as the cloud server. Then we decide that the data must be processed at the fog server. So the fog server, which is an intermediate server between the cloud server and the edge server, will collect the data and do the necessary processing, and will act as the cloud server, and it will give the necessary useful information and feedback to the IoT network, right? To the IoT network, the fog server will give feedback, and also if there's an intermediate person who's accessing the network, they also will be able to get the useful data out of regarding this industrial IoT network, for example, by connecting to this fog server. right? So the fork server is an intermediate server, right? And it is also capable of doing processing up to a certain extent. Rather than sending directly to the cloud server, you can also do some processing at the fork server. However, the cloud server is mainly known to do a lot of computations, I mean, with very low latency, because of its ability to do a lot of computations using its resources. The cloud computers are having a lot of resources, right? So therefore, they are able to do multiple computations at the same time. So the amount of latency for the computation is less there. However, fork server might not have that much resources. It will have medium resources, and it will do the computations necessary on its from its side, and will support as much as possible from its own side. So basically, the fourth technology that will enable the IoT networks, industrial IoT networks, is edge computing. So edge computing is especially required in order to like process and send only the useful data, transmit only the useful data to the network, right? Transmit useful data, and also to provide low latency, provide low latency uh, feedback, right? So once the devices that are connected to the IoT network requires feedback very quickly regarding the environment that it is in, then um, the edge server is able to do the necessary processing and give back the feedback with low latency. So real-time updates will be enabled once edge computing is available, right? So I hope it is clear to you. If it is not clear to you, please, is required in situations where we require where we want very low latent feedback, low latency feedback, very quick feedback. Okay, and we need real-time updates regarding the environment. We don't have much time for waiting. We don't have time to wait, right? Sometimes in the industrial scenario, we need very quick feedback from the edge server or from the network. We need very quick results. So in that case, the edge server can do the computation up to a certain level. So, and it can give some useful information back to the devices to which it's connected. Okay, so it could be like in situations where edge computing is useful in situations where we are monitoring the environment, for example, right? Monitoring the environment. So when we are monitoring the environment, so we have some parameters that we take into consideration, for example, the air quality, the quality of the air, right? The humidity of the air, and then the temperature of the air, let's say. So in that case, like if we want this kind of feedback regarding the environment, then rather than sending all the data to the cloud server and waiting for the monitoring data, or waiting for data regarding the industrial environment to come from there, it's beneficial if if edge computing is done, because the edge computer will be able to give back give feedback regarding the environmental condition by doing the necessary processing of the data, right? Edge server will collect all the data regarding the environment from all the devices that are connected to it, and then by seeing all the data, it will decide what is the air quality, what is the humidity in the facility, what is the temperature in the facility. Likewise, it will decide, and based on the requirement, it will transmit that data back to the devices who are requesting it. The devices which request such data will get that data from the edge server. Okay, so I hope it is clear to you. So we have talked about three technologies so far. The first one being the artificial intelligence and machine learning. Second one, cybersecurity. Third one, cloud computing. Fourth one, edge computing. Okay, so now we are coming to the fifth one. So fifth technology basically is the data mining technology. Right? How we can manage the data. Okay, so data mining is about how we can organize the data and like see observe patterns in the data, right? So I mentioned about this earlier as well in today's class. So data mining is collecting data from different elements, right? So from different elements of the IoT network, different elements of the IoT system. Okay. And discovering meaningful patterns uh, from the large volumes of data. We call large volumes of data big data. So I will write big data here. So in IoT networks, like in industrial IoT networks, as we talked about in the last class, we have different types of sensors, right? We have like normal sensor nodes with temperature sensors, pressure sensors. Likewise, we have different sensor nodes, like which measure the parameters of the environment in the facility, right? Air pressure, right? We need these kind of parameters all the time: air pressure, quality of the air, and moisture content of the air, humidity of the air, the temperature, right? Also, we will have some cameras to watch the process happening in the industrial scenario. So different sensors are there in the industrial facility, right? So those sensor nodes will be connected to a PLC, which the PLC will collect all the data and process the data sufficiently, right, as required, right? PLC will process the data and it will transmit the useful data uh, to the access point to which it's connected. Let's say this is a router. So if it is so if so we have if we have a wired connection to the router, we can transmit it and communicate to the router. Then we have other devices which are different, right? Other equipments like computers, right? Computers, user interfaces, which uh, which are also collecting data and which are connected to the PLC. Okay, so also we have robots in the facility, which are used to do some task in the industrial facility. So all these can be connected to the PLC, and also the PLC will send that data to the router. Also, the robots can directly connect with the router as well using wireless communication. So the router will collect all the data from the different components. So the data that is collected will be different. Like the type of data will be collected. The types of data collected will be different. Different types are collected, right? So some data will be regarding temperature. some data will be regarding the process of the industrial. I mean the devices will give some data regarding the process industrial. I mean process, some data regarding the industrial processes, right? So I think you know about industries a lot, right? So you know how the facilities work. So the data regarding processes in the industry will be connected by the devices. The robots will collect data regarding the environment and also regarding the current status of the current status of some kind of a action that is happening in the environment, right? So the robots will be giving another type of input or input data to the IoT network, right? So different types of data are there. So different types of data needs to be organized, properly, such that useful information can be observed in the data, right? Useful information, which means like patterns, right? So some patterns or some knowledge can be taken from that data. Okay, so in order to do that, we do something called data mining, where we are actually doing we are processing the data, and we are cleaning the data, and we are preparing the data to uh, uh, to observe useful information in the data, right? Observe useful information, right? So in order to observe useful information, we need to prepare the data first. So under preparation, we will be cleaning the data. We will be removing unnecessary duplicates, so removing like unnecessary data, removing unnecessary or erroneous data, right? Removing erroneous data, and then we are cleaning, and we are like forming the data set in such a manner that the data can be analyzed easily. Okay, so we are like forming the data in an organized manner, forming organized data. So I hope it is clear to you. If you have any questions, please let me know. So with that, the key enabling technologies of IoT, industrial IoT systems will be over. So key enabling technologies will be mainly those technologies, but there are other technologies also that will be enabling the industrial IoT systems, right? So these are the technologies that are mostly used in these current days, current systems, and in the current, these in the present days. More technologies are evolving in the world, so so new technologies can be added. It is changing every single day, so we need to keep an eye on what are the technologies that are useful for us. So depending on the like different application that we are considering or we are using, right? However, like now we talked about industrial IoT systems, right? We talked about how it can be beneficial for us to like improve the performance of IoT. Improve the performance of the industrial facilities, right? So the performance in the industrial facility, how it can be improved, we talked about in the last classes and I think in the today's class. So the industrial facilities and its performance in the industrial facility can be improved using industrial IoT networks. However, there are some challenges that are available, that are remaining, that that IoT networks, right? So the first challenge would be um, like managing the data, right? So data integration. So we call this as data integration. So as you know, like industrial IoT networks, so IoT networks in general have a lot of sensors. So we have a lot of data, large volumes of data. So the data that is collected at the access point is like large. So the large volumes of data needs to be managed and needs to be integrated into our processing unit, right? So large volumes of data are there. So it's like that data must be properly managed in order for us to get the useful outcome of such kind of data. So need to be properly integrated into the IoT network, right? Properly integrated into the IoT network, and also we need to manage the data sufficiently such that the data can be useful. Uh, so in order for us to get a useful output, uh, we need to manage the data, right? So we need to manage the data in order to get a useful output from our data collection, right? There's no point in collecting data without getting some kind of a use out of it. So we need to integrate and manage the data properly, so into the correct in the correct manner into our computing in our cloud computing platforms. In our computing platforms, we need to integrate the data correctly into the computing platforms. I hope it is clear to you. So the second challenge is like how we can use new hardware and software in our IoT networks. So how we can use new hardware, software in our IoT networks, right? So in order for us to implement this industrial IoT networks, we need to install like new communication modules. As I said, we need to in order for us to build connectivity between devices and between sensors, we need to install the necessary communication modules in all these devices. So in order for us to install those, we need to we need to buy hardware, that is technology that we are using, depending on the microcontroller that we are using. We need to install that in all the devices in the industrial network, right? So in order for us to install that, we need to buy all this hardware, right? And also we need to install the software that is required in these processing units, right? So in order for us to do the communication between the devices, between the sensors in the IoT network, then we need specific hardware, we need specific software, right? So therefore we need to buy them, we need to invest on them. So we need to invest on the hardware and software. So this is a challenge in the IoT industrial scenarios, mainly because it is costly, right? So cost of the implementation is high, right? So that is a challenge, right? So the third challenge we will discuss now, which is the lack of expertise. Okay, so the training workforce, and hiring new staff, is a challenge when it comes to industrial IoT networks, right? So we need to actually train the workforce to we need to train the workforce to enable them to use IoT networks. First thing, so Internet of Things based industrial environments means like the workforce, people who are working in the industry must know how this technology works. They need to know how to operate the devices that are like connected to the IoT network. Okay, so the sensor nodes and the devices, maybe the robots, those things will be connected to the Internet of Things. So these robots and these sensors, how they function, how they should be maintained, and if there's something wrong with them, how can we like detect them? Such things can be, such things can be, taught to the working force. Okay, so we need to teach the working force to how we can operate these devices and robots and sensors, right? Hire new staff that can implement this technology in the industrial facility, and also that can like manage the security, for example, in the IoT networks. And if some kind of a networking fault is there, the these new staff members must be are required to fix such kind of communication errors and communication failures that can occur in the industrial IoT scenarios. Okay, so basically in industrial IoT scenarios, we need to maintain the connectivity basically between the devices, and we need to make sure that the connectivity is extended up to the local area network and up to the public network. Okay, so the connectivity between the devices must be enabled, and the connectivity must be extended to the local area network in the industry. And after that, the data must be also extended. The data communication must be extended through the public internet to the cloud computing platforms, right? So therefore, all these must be handled by expert people who know about these technologies. So the expert people must know about cloud computing. They must know about the public network, how the networking can be done in the internet, the public network, and how the networking will happen inside the industry, and how the networking will be done between the devices in the IoT network. So such challenges are there for the new staff, and we need to have the expert staff to handle the industrial IoT network. So the IoT network in general. Okay, so the next challenge is the cyber threats. So actually, cyber security we talked about in the in previously also. So basically, security-based threats are like hugely impacting the networks. So therefore, cyber attacks are expected in the IoT networks, and it is very challenging, especially for industrial IoT networks, where the industrial industrial IoT networks are meant for industries, right? So the industrial authorities, they do not like to share their um, data with unauthorized people, right? So industrial or managers of the industry, right? They do not like to share that they are they do not like to share their confidential data regarding the industry, right? However, once we connect our data, our once we send our data through the public internet, anybody who's accessing the public internet can access our data if we do not secure the data sufficiently. Therefore, this is necessary for us to make sure that the data that we send from our IoT networks to the internet must be secure, right? So the data that we send must be sent in a secure manner, uh, and we need to send the data by adding encryption um, uh, techniques into the data, and we need to use username passwords based authentication methods uh, to only allow the authorized people to access the data. So the data must be securely sent, and the data must be encrypted, and techniques related to that must be used. So the encrypted data must be sent through the network, through the public network, right? Such that any person who's accessing such data will not be able to decode the data and get the data. So any person who's intruding the network must not be able to get the data and decode the data. So if that person is able to decode the data, then that person is able to also find your confidential data. Such confidential data can be used by that person to access your networks and observe the environment of your network. So if that is possible, then the network is not safe. So if that person is collecting data regarding your network, then that data that the intruding person will collect will be used by that intruding person to do some damage. Some damage to your network. Right? If it is industrial scenario, then that person is able to uh, to provide a threat, or to give, or to um, give a threat to your network, to your industrial facility. So cyber attacks is something that is people are looking into in these days. So this is also one of the challenges to to the industrial IoT networks. Okay, so with that, I'm ending about the challenges to the so those are the challenges mainly that we can have for the industrial IoT networks. Those are some of the challenges. This is not the only challenge, but these are the kind of main challenges that uh, I am presenting in this lecture, right? So industrial IoT is not something that is that is not something that is totally imaginary. Okay, so industrial IoT networks are already available in some countries. Okay, so mostly in countries like US, it is already available, right? So there are some companies that already implement this industrial IoT networks, industrial IoT technologies, right? So some of the companies are Electric Company, General Electric Company. So you can search about that also. So General Electric Company, we call it as GE. It's a very popular company for producing um, things like motors, engines that are required for applications like aviation, healthcare, lighting, right? And for production processes, right? So this company has already incorporated industrial IoT concept into their industrial facilities, right? They have already incorporated industrial IoT in their companies. So, the second company is Siemens. So Siemens is also related to electrical product manufacturing. So Siemens is producing electric machines, machines related to healthcare, etc. So this company is also said to use industrial IoT technology. Then John Deere. This company is specializing for agricultural product manufacturing. So it also is known to incorporate the uh, the industrial IoT technologies. Okay, so John Deere is also another company which is implementing industrial IoT technologies. Okay, so basically, industrial IoT is like used in many industries related to uh, manufacturing. Okay, so manufacturing facilities will be using industrial IoT. Also mining oil, oil and gas, uh, those processes. In those processes, also industrial IoT will be implemented and can be used. In pharmaceutical, so industrial IoT can be implemented in pharmaceutical or healthcare industries, right? Healthcare industries and in that field. Also in agricultural field, the industrial IoT can be used. Okay, so these are the kind of applications where the industrial IoT can be used. Okay, so basically that is regarding industrial IoT. So at the moment, the main challenge, right? I mean, the main challenge in implementing in implementing the IoT networks is the cost of implementation. Okay, so is the cost of implementation, right? So the challenges I talked previously were the challenges that come after implementing the IoT network. So the challenge that comes before implementing is actually the cost of implementing the IIoT networks. So cost of IIoT is high. So sometimes the company owners are reluctant to implement the IIoT network because of that reason. Okay, so that is basically regarding industrial IIoT networks. So do you have any questions? Right. So if you don't have any questions, I will also now go to the next, thing I want to discuss. Right. If you have any questions, please let me know. Right. So I will actually share with you the I mean uh, some sample exam paper. Okay, that might be that you can prepare yourself before the end exam. Okay, so I will first this is actually not a new thing. Okay, so I have already discussed with you regarding the fact that I will be focusing on the the fact uh, same format that I have given in the tutorial in the tutorials, and I will focus on the tutorials and the questions that I have discussed there in preparing the end exam. Okay, so this PDF that I'm sharing with you is like is actually the collection of two such kind of tutorials that I have given to you. Okay, so the first question is the first tutorial that I have given to you. So the so so basically like in your end exam, you will be having 4 questions, each with 25 marks. Okay, so the question will be like this. So one question will be having 25 marks, and each part will be given specific mark. So based on the mark that is given, you need to decide how much you need to write for that question. Okay, so if it is a low mark, you don't have to write much. You just have to list out the required answer, and then you need to just go ahead with the other questions, right? If it is given, like if that question is given a high mark or I mean lot of marks, then you need to write a lot to that question. Not a lot, but according to the I mean according to you, I mean to the level of the question that is asked, you just need to write a little bit more than the other sections with low marks. So the first question is the question that I have given in tutorial 1. So in that question, I have given like basically 5 subsections. So you need to answer all these questions, and the marks that are available given to these the sections are given in this in the paper, right? So you will be hoping to give like a closed book exam. So you need to prepare beforehand to write the answers to the question, right? And then you can also you need to actually prepare well before the exam, right? So like in this first question, you can see there are so many things that I have asked in that question. So it covers like sections related to sensors, the sensors that are required for the IoT network, right? So different types of sensors that you'd require for this IoT network is asked, right? Then it is asking regarding the communication technologies that are useful for the IoT network, and they are asking like which type of network technology you need to use specifically in your network, right? So likewise, there are some some challenging questions that you need to prepare beforehand to prepare for this kind of exam question, right? So you need to learn about the technologies that I have taught you, and you need to answer with the correct uh, out correct um, information. And right, so we have actually covered many sections regarding this. So we will, I mean, uh, if you so I will discuss about this in a brief manner. Okay, so the uh, right, so I think I want to uh, I want to share the whiteboard again, so I will stop sharing this. Right, do you have any questions regarding the exam paper? Okay, so I will explain regarding that a little bit, right? So exam paper will contain 4 questions. Okay, so each question will have 25 marks. Right, I will provide you with a sample exam paper. Right, So yeah, the sample exam paper I will upload to LMS. Okay. So however, the exam paper is not the exam paper. Okay. Something similar will be given, but not the exact thing. Okay. So, I mean, something similar will be given, but not the exact thing. Okay. Not the same thing. Right. Some similar paper will be given at the end exam. So you can, but not the same thing. Right. But not the same thing. So, um, each question will carry 25 marks. There will be subsections which will carry some definite amounts of marks. Right? So 3 marks, 5 marks, likewise. So if the mark amount is low, then you don't have to like spend a lot of time on that. You just point out the answer. If it is given a lot of marks, then you can describe a little bit depending on the time that you are having. Right? So if for each question you can take 30 minutes and you can cover the 2 hours by working like that, right? So basically, I will upload this question paper. So it is having the tutorial questions that I have discussed before, right? Apart from that, I will add 2 more questions to this exam paper, right? Currently, I'm only having 2 questions, right? So, so currently I'm having 2 questions. So the first question is regarding the uh, the first sections that I have covered in the course. Okay, so the first sections that I have covered in the course uh, have discussed about sensors, different types of sensors. Uh, so uh, so we use different types of sensors for different type of measurements, um, such as temperature, humidity, moisture content, then uh, right. So the obstacle prevention, like infrared like sensors, right? Identify obstacle identification, and then like camera or images, right? Like images from cameras, right? So different types of sensors can be used. So we talked about several sensors, and so I mean, I will not. I will not ask you to like maybe ask you to maybe it's okay that I mean if possible you can actually refer some sample like example sample sensors available in the industry. Okay, sample sensors available in the industry you can refer and you can study them and come to the exam. So if you can provide the like the type of sensors that are used, like for example for temperature sensors there's something called DH, some kind of code is there, so you can mention those kind of things in the exam paper. These kind of sensors are there, maybe you can draw them, right? You can draw the sensors and you can show like what are the pins that are available and what is the look of that sensor and so on. So you can get some information and you can study about the sensors, and then you can answer the questions where I mean you are asked like what are the type of sensors that you can use in a specific IoT network, right? So IoT networks can be used in different applications. So in most of the applications you can use some I mean general sensors. So you can prepare beforehand for different types of applications regarding IoT. I mean, regarding IoT systems. Okay, so IoT based applications you can think of, and then you can think of what are the sensors that are required for such kind of applications. Okay, so in the first question in this paper, I have asked about the smart agriculture scenario. So for that smart agriculture scenario, you need temperature sensors, humidity sensors, air quality sensors, and then you can have soil moisture sensors and so on. Apart from that, you can also install cameras as well. So those things can be taken as sensors. And then we can, I mean, you can suggest many sensors for the application. Then we can have communication technologies that we can use in that environment which uses this IoT network, right? So we can use different communication technologies, right? So based on the application, you can use the optimal technology. And so in the second question, I'm asking, like, out of the technologies such as RFID, NFC, Zigbee, Wi-Fi, Bluetooth, what is the best technology to be used in this uh, uh, in this scenario where we need the communication up to 1 kilometer range from the access point, right? 1 kilometer range from the access point. Okay, so uh, so so from the access point. Okay, so so the question is asking, like, what is the best technology that can communicate up to about 1 kilometer range uh, from its location, from the sensor's location. So you, in order to answer this question, you need to refer about the different communication technologies. Okay, so I have discussed about different short range communication technologies. So you need to refer about those, right? So mainly regarding those communication technologies, you need to know basically the different parameters such as the communication range, energy consumption, and the data rates of that communication technology. Okay, so I will erase these. Do you have any questions? Okay, so I will write about the communication technologies also. The communication technologies that are used for short range, right? Uh, we can categorize based on their communication range, right? Based on the communication range and based on their power consumption, based on their data rates mainly. Okay, there are other parameters also. These are the main parameters that are that is important for us. Okay, for the IoT scenarios, we need to know whether our communication will be reached at a certain range, at a certain distance from the sensor node, and we need to know, like, what is the amount of power that is required by the sensor node to transmit that data, because we need to power up the sensor nodes in some kind of uh, energy supply, right? Okay, using some kind of energy supply unit, we need to power up our sensor nodes. So we need to know what is the power that is required to transmit the data using this communication technology. So based on that power that is required, we can manage the energy consumption at the sensor node, or we can plan the required energy level at the sensor node. So by that plan, we can decide, like, what kind of energy um, source we need to apply for this scenario, right? Whether we can use batteries whether we can use solar power, whether we can use any kind of other, energy supply to power up our devices. So the different technologies, as I mentioned, can be divided, or can be uh, categorized based on the communication range and power and the data rates. So once we take technologies, we can write one as Bluetooth, right? Bluetooth technology as one of the popular short range communication technologies. So the communication range of that is about 1 to 100 meters. Okay, so how its power level, the power that is required is about medium power consumption. Also, the data rate is also able to reach up to megabits per second, up to 3 megabits per second. So Bluetooth is this Bluetooth is showing this performance. There's also another category called Bluetooth low power energy. Bluetooth low power, low energy. Bluetooth LE, BLE is and I mean Bluetooth low energy. We call this as BLE, Bluetooth low energy, is having low energy consumption. Low energy consumption, its communication range is up to about 10 kilometers, right? So up to about 10, sorry, it's not up to 10 kilometers. It is not able to do that. It is able to reach about 100 meters. It is able to reach more than 100 meters, but it is also not reaching very high distances. So it is below 1 kilometer, right? It is able to reach 100 and beyond that, but it is not able to reach very large distances like 1 kilometers. Okay, so 120, uh, 125, yeah, 125 kilobits per second up to again 2 megabits per second. So this is also able to reach megabits per second level, right? So you don't need to remember these values, you don't have to mention these values, just mention that you can reach megabits per second range of data rates. Okay, so up to 1 to 3 megabits per second is able with the Bluetooth. A lower amount is able with the Bluetooth low energy. So because of the low energy, we have low data rates and low power consumption. However, the communication range is enhanced because of the low, power that is that is uh, that is applied, and also the data rate is low. So we don't have to reach higher data rates. So once the data rate requirement is low, then we can send the data to a large distance without much error in the data that we communicate. Okay, the data can reach uh, uh, a higher range than the normal Bluetooth with high reliability, right? So you can research about that. So then technology, LoRa technology. LoRa technology is the technology that can reach a large distance, like a high amount of kilometers. Okay. So it is said that it can reach up to 5 to 15 kilometers. Uh, it also uses low power consumption, right? It can reach higher communication range, but it can have low energy, but it has low data rates. It only has kilobits of kilobits of kilobits per second range of communication data rate, right? So kilobits of kilobit range data rate is only possible with this LoRa communication technology. Okay, so although we have advantages in terms of communication range and the power consumption, we are not able to transmit large amounts of data across that communication range using this technology. So in cases where we need to send large amounts of data with higher data rates, we need to use other type of technologies. Okay, so once we consider Wi-Fi technology, Wi-Fi is actually in the indoor scenario, it is only able to go up to about 10 to maybe 100 meters. Okay, okay, so it is not able to travel very far. Okay, so normally it is able to do communication in the indoor scenarios. However, like if you are using Wi-Fi extenders, then you can extend the Wi-Fi communication to large coverage. Okay, but the like one access point is only able to do communication over a short range, right? Because one reason is that it is it is having high data rates. It's giving high data rates. Once it is giving high data rates, then it needs to uh, uh, it needs to I mean send the data with high power, right? High power, right? With enough power to the receiver. So the receiver must be located at a short range in order to receive the high power signals from the Wi-Fi access point. Okay, so the receiver must be within 1 to 10 meter range from the Wi-Fi access point to receive the signal, appropriately with the appropriate power, and such that we can receive the data very quickly and reliably over a short time duration. Okay, so the data rates are high with the Wi-Fi, but the communication range is low in that. Okay, so then we have Zigbee communication. It is also a short range communication technology, and it is available up to about 1 to 100 meters of communication range. Okay, and it is, however, uh, it is also, useful for low energy consumption applications. However, it is able to do 20 to 250 kilobits per second amounts of data transmission per second. Okay, so kilobits range of communication it is able to do. So these are the main type of technologies that are used for short range communication. We can also consider some other types like NFC, RFID as well. So I will write those two as well. So to complete this comparison, okay. Um, right. So another type of technology that can be used is NFC. Let's say NFC. Okay. So NFC is having the communication range below, actually below 10 centimeters. It is saying, okay. So 10 centimeters. So NFC is a technology that is used for very short range communications and very low range communications. So it is used for payments like without touching, like right, once you keep the devices very close to each other, uh, we can do NFC communication only in this situation we can do it. So the communication distance will be very low. It's like below 10 centimeters, right? It cannot communicate more than that. Right, so with the current technologies it is in that communication range. Then RFID is also a short range communication, and it can communicate up to about 10 meters. How so NFC has a lower communication energy consumption, and it can communicate with the kilobits range. Okay, so it is also able to communicate about kilobits per second range of data. So it can communicate about 400 kilobits per second about of data per second. And then RFID technology is also useful, and it can communicate up to 10 meters. It is having low energy consumption. It can communicate about 40 kilobits per second. So actually this is 400, this is 40. So RF communication range. So likewise, we can categorize the communication technologies. So based on the requirement, we need to select the best communication technology for our application. In the sample paper that I have provided, I have asked like, what is the communication technology that we can use for communications that that is reachable, that is suitable for 1 kilometer range, right? So out of these technologies, what do you think is the best communication technology that is suitable for 1 kilometer or above communications? For communications within 1 kilometer or above, what is the technology as you think is suitable? Yeah, so we can actually select the LoRa communication technology for cases where we have more than 1 kilometer range of communication. Okay, so it is energy consumption is low, and however it is data rate is low, right? So the data that we transmit uh, must be having a low weight, right? We can send kilobits per second of data, but the if we have large volumes of data at 1 second, we cannot send large volumes, but we can send kilobits range of data. I hope it is clear to you, and we will move to the next question in that paper. So in there also I'm asking about the network protocols. So in our lessons, we talked about the network protocols that can be used for IoT networks, right? So basically, we discussed about three main network protocols, and we discussed about specifically about the 6LoWPAN protocol, which is useful for IoT constraint environments. So so this exam paper is asking about that IoT constraint environments and what is the network protocol that can be used for constraint environments, right? So IoT protocols that can be used in the network layer can be mainly divided into there can be mainly three types. So we can use uh, internet, I mean IP-based protocols. IP-based protocols. So actually two types we actually discuss, IP-based protocols and the 6LoWPAN protocol. So IP-based protocols, we were actually protocol and IPv6 protocol. And under 6LoWPAN protocol, we discuss now about how we can use 6LoWPAN protocol, which is integrated with the IPv6 protocol as well, to communicate in a constrained mesh network, which is not directly connected with the network infrastructure, right? So we will actually, I will draw a diagram. Okay, so this is IPv6 over low power wireless. Okay, a personal area networks. Okay, so 6LoWPAN stands for IPv6 over low power uh, wireless uh, personal area networks. So it's actually long definition. However, this is the definition of 6LoWPAN protocol. So 6LoWPAN protocol is used for energy constrained environments. So energy constrained environments means the network devices are not having a lot of energy level in their devices, not enough battery in their, or not enough energy, not enough power supply in their environment. So we can take a situation where we have but battery powered sensors, right? So these sensors are battery powered and the battery is limited. So these sensors will uh, can be connected using certain communication technology, certain communication protocol that we that we that we uh, that we discussed earlier, right? We discussed about different protocols like Bluetooth, Wi-Fi, and Zigbee, and so on. So any of those technologies can be used for the communication in the physical layer, right? So the physical layer communication can be done using technologies such as um, the Bluetooth, Wi-Fi, Wi-Fi direct can be used. Now, if the Wi-Fi access point is somewhere here, right, edge router, we call, right? So the edge router is connected to the, it will connect to the internet and so on, right? So until the edge router is until we connect to the edge router, the sensor nodes in the IoT network must connect to the edge router via another short range communication technology that they can use, right? So they can use Bluetooth, I mean, direct Bluetooth communication. They can use Wi-Fi as well. If the Wi-Fi modules are available in all these equipments, they can directly communicate via Wi-Fi with the other device. And Zigbee technology also is available. Apart from that, there are other technologies like low pan, LR pan technology, which is known for, which is known as low rate personal area networks, personal area network technology. So this is having a low rate and low power consumption. So this one also can be used for short range communications in these kind of environments. So anyway, so these kind of technologies can be used to communicate between the sensor nodes. Then in order to manage the data packets in the network layer, the 6LoWPAN protocol can be used. Okay, so in the network layer, the 6LoWPAN protocol can be used. Okay, so 6LoWPAN protocol can be used, right? So the difference between IPv6 and the 6LoWPAN protocol is that the header is compressed. Header is compressed um, in this data packet such that the data bits of the total data packet is about 127 bits. So therefore the data packet will be lightweight, and therefore the communication will be much more simpler and easier through this network. Okay, so therefore like 6LoWPAN protocol is a protocol that we use for energy constrained environments. Right, so you can let me know if you have any questions. That is basically regarding 6LoWPAN. And then we have protocols that can be used in the application layer. So application layer protocols we learned, again, some multiple protocols we learned, right? So application layer protocols also can be divided mainly into maybe four types of protocols we discussed. However, like for energy constrained environments, there are basically specifically two protocols that we can use. Basically, MQTT protocol, right? So in these environments, we can use application protocols such as MQTT and COAP protocols. Okay. So out of MQTT and COAP, if the network is very complex or very constrained, what do you think is the best protocol to use if we do not need high reliability, but we need low latency? Right, in this exam question that I have, exam paper that I have provided, I'm asking, like, out of the application layer protocols like MQTT and COAP, if I need low latency over high reliability, if I need low latency more than high reliability, what is the best protocol that I can use out of these two? As you think, what is the best protocol that I can use instead, out of these two? Yeah, so COAP is a protocol that you can use for constraint environments. Okay, COAP is basically a client server based model. Okay, so basically you are sending some request and you are getting some response back from the server or the other device, right? So you are sending a request to the other device with whom you're communicating with, and then that person is sending a response to you. Okay, so this is the basic model of communication in the COAP model in the protocol. So in there, actually, this kind of a communication is happening. You're sending a request and the server or the other receiver will, uh, if you're transmitting some data, then the receiver will send you a response. That's all. But once you consider MQTT, MQTT is having, like, if you're having two people who are communicating, there should be a broker in between, some kind of a person who's communicating or who's handling the data between your communication. So you first need to send to the broker, then the broker needs to send that data to the receiver. So in that case, when where your data will be kind of stored inside in the broker and sent to the most suitable people who should be receiving the data, right? So in that case, like, more reliability is maintained. However, the latency is high. So high reliability is there, but the latency is also high. So therefore, in situations where we want to very quickly send the data and we want very low latency, we can actually, we might not be able to use MQTT as the best method. We can actually consider using COAP as the best method, right? So that is the kind of the optimal answer. Okay, so right, so we talked about the protocols on the physical layer, network layer, transport. So transport layer protocols we discussed in the lectures. Basically, two types of transport layer protocols are there, right? UDP and TCP, right? So uh, based on the application layer protocol, we need to select the transport layer protocol, right? So if we are talking about the MQTT protocol, in the application layer, then we need to use the TCP protocol in the transport layer, right? Transport control protocol, right? And transmission control protocol, right? So MQTT protocol stack, once you consider the MQTT protocol stack, we mostly need to use the uh, TCP protocol as the transport layer protocol. So as the network layer protocol, we can use the 6LoWPAN, and as the physical layer protocol, we can use Bluetooth, Wi-Fi, but something that is suitable for our application. Okay. So um, so I will write all these things down. Uh, right. So in the next question after the MQTT and COAP question, what I have asked is about the protocols that you'll be using under each layer. So this is the protocol stack basically that you can use for this application, right? So you can do the low rate personal area network protocol, right? Zigbee protocol also can be used, right? So for like low power constraint scenarios, right? What is the best technology you can use? So that is what you need to consider about, right? So actually, I think Wi-Fi cannot be used for constraint scenarios. So you need to use technologies which use less power. Okay, so Bluetooth consumption, power consumption is low. Bluetooth um, low energy protocol has low power energy. I mean low power consumption. So BLE protocol, Zigbee protocol. Zigbee protocol is also having low power consumption. Yeah, it is having low power consumption. Uh, apart from that, uh, we can take that low rate PAN protocol that I mentioned, that also has low energy consumption. So the communication protocols that have low power consumption can be used for this energy constrained environment and the IoT networks there. So the network protocol, as for the network protocol, we can use 6LoWPAN protocol, which is specifically designed for the constraint environments. Then as the transport layer protocol, uh, we can use the specific protocol that is based on the application layer protocol that we use. So if we are using COAP, we need to use the UDP, because COAP is based on the UDP transport protocol. It is built on the UDP transport protocol. So you need to correctly define the transport protocol based on the application that we are using. If we are using the application as MQTT, then we might need to use the TCP protocol in the transport layer. If we are using COAP, then we can use the UDP protocol in the transport layer. It is the transport layer protocol is designed or decided based on the application protocol. Okay. Then in that question, lastly, I'm asking like, what is the total network architecture diagram, right? Diagram of the total network architecture. So what type of sensors you are using, right? Also so you can mention these as sensor nodes, not as sensors, right? So sensor nodes will be consisting of three components: sensor, controller, and the communication modules, right? So there will be controller, there will be communication modules. So based on all those things, we call the sensor based controlling and communication unit as sensor node. So the sensor node is what is at the edge of the IoT network, right? Oh, these IoT devices will be connected to the IoT network through a certain communication technology that you consider, right? So if it is a smart agriculture scenario, then we might need to connect our communication links to the base station that is available in the nearby area, right? So we will take this is as the base station. Okay, so the base station will have direct communication to the core network, right? So the core network will be able to connect our data, right? So the core network will be connecting our data through the internet to the server to which the user is accessing. The server could be connected to certain router, and the farmer who's accessing the data will access the data through the internet and will access the server in which the data is stored in. So this could be a cloud server. So a server which is available in the cloud servers, right? So this farmer could be remotely monitoring the environment. Okay, so the farmer could be in another network which is connected to the public internet. Okay, so if the farmer is not in the local area network, then farmer can access the cloud server and get the data, right? If the farmer is in the local area network, then the farmer can access the local area network and access the data. Okay, so um, uh, so the depending on the location of the farmer will access the data. Okay, so you need to label each of the components that are used in the diagram, right? So you can label the internet, uh, the cloud server, the routers, the access points. So likewise, you can uh, mention those things. Okay. So do you have any questions? So that is mainly regarding that first question. Then secondly, I have the second question regarding software defined networking and network function virtualization. So this question I talked before as well. So you can actually refer that and you can understand that question. So in there also, I have given marks for the sections depending on the weight of the answer that I request from you. So if the marks are higher, you can write more for that answer, for that question. If the marks are low, then you just need to list out the facts that I'm asking from the question. Okay. So, so basically, that is regarding the questions in the exam paper. So if you have any questions, you can reach me via email, and you can call me if you want. So if you have any questions today, you can ask. So in the next class, I will be doing rest of the lectures regarding data analysis of the IoT networks. So I will be discussing a little bit about machine learning and related facts. So after that, I will be again discussing some things related to exam paper, and I will be discussing how you can answer those exam papers. After that, I think I will be ending the lectures for the IoT. If you have questions, I think you can reach me via email. So I think I have covered all the content. So you, so if I feel that I haven't covered some kind of a content, I will discuss questions with you regarding that, and I will cover that content. Okay, so basically that is regarding the lectures. So in today's class, we discussed mainly regarding industrial IoT, its enabling technologies, its challenges, uh, its real world implementations, and the challenges in the real world implementations, right? The cost wise, like why actually people are not still implementing it in the real world in some cases where it is very costly. Okay, so with that, I would like to end today's class. I will stop recording.